Hello guys, in this lecture we are going to learn how generators benefit our Python programs. Generators are functions that we can use them as iterators. Unlike lists, generators generate items one at a time. That's why generators are much more memory efficient when dealing with large datasets because they don't hold all data in memory. And this is very important because if you want to create good Python programs, we need to use generators. And some people, when they try to learn generators the first time, they can get confused, but don't worry, you can make some researches on the internet, if you watch more videos and if you see more examples about generators, you will understand generators. Don't worry about it. And also I will try to do my best to teach you how generators work. Okay, and here first I will create a formal function. After that I will create a generator, and we will talk about the difference between formal definitions and also generators. Here I will say def func, and for argument I will say nums. Okay, I want to create here an empty list. Okay, and its name is result, and I will say list. Okay, and now I will use for loop to append all my items to my list. Okay, and I will say for I in nums result dot append I. Okay, that's all. And what I need to say here, I need to return my function. I will say return result. Okay, and after that here I will say x equals my function, and let's say range 10. Okay, and the last thing I will print it out. I will print out x. Now if I press shift and enter, as you see, this function, it works well and everything is like before we know it. It's normal regular function. It's a formal function. And now if I want to create a generator, how can I do that? I will copy these guys and paste them here. Okay, now I will not use list. Okay, I don't need to use a list for generators. Okay, and also of course append method here, and here for the return, let's delete this also, and I will try to explain this here. Okay, here for the return I need to use yield keyword. Okay, for the return, and for the return it's like it must be indented. Okay, here, not right here. Okay, and after that what I will yield I, or you can say I times I, or what you need. Okay, I will yield here I. If you see yield keyword in a function, that means this is a generator. Okay, because you will never use return keyword for instead of yield if you create generators. And after here, let's name it gen. Okay, is equal to, I will say here 5 because I don't want to repeat my code. And after that here I want to print out my generator. Okay, if I press shift and enter, as you see, Python returns me generator object function at here in the memory, right? It said. Okay, so but I didn't print out any item from my generator. How can I do that? To do that I need to use here print next keyword. Okay, and I will say only next, and my generator function name is gen. If I press shift and enter, as you see, my first item is 0, right? Because of range 5. First one is 0, 1, 2, 3, and 4. And if I want to print the other guys also, I need to use again next keyword. Okay, for 1, this is for 2, for the 3, and for the last one is 4. Let's press shift and enter. As you see, we already printed out 0, 0, 1, 2, 3, 4. Because as I said here, generators generate items one at a time. Okay, if I try to print out again my item from my generator, what I will get, let's see it. As you see, I got an error. It is stop iteration error. Because why is like that? Because our generator is exhausted. There is no item left. Okay, that's why we will get stop iteration error. How we can solve this problem? As we know, already we learned we can use try and except block, of course, but there is better way and simple way simple way to print out all items from our generators. As we said here, generators are functions that we can use them as iterators. For iterators we can use for loop, right? And I will also use for loop too, and I will say for item in my function is a generator gen, okay, and after that here I will say print item. That's all. Now let's check it. As you see, now here you need to refresh your generator, and after that if you run your code is better. And now if I use for loop, as you see, I printed out all my items from my list, okay. Also you can, if you want to print out your generator items, you can use for loop. Here I want to talk about something. Almost all standard library functions return list in Python 2, okay. But after that they have been modified to return generators in Python 3 because generators require less resources. That's why now in Python 3 all the standard library functions return generators, okay, mostly actually. And here what is next, I want to here create a Fibonacci sequence, okay, with generators and with formal function, and we will talk about the differences here because it is really nice example to understand how generators work and how they benefit our programs, okay. Firstly, I will create a generator function, and to do that I will say def gen Fibonacci, okay, and here I will say a comma b is equal 1 and 1, okay. After that I will use here while true loop. What I need to use for generators, as you remember, I need to use yield keyword, right? I will say here yield a, okay. After that I will say a comma b is equal to a is equal b, b is equal to a plus b, okay. And after that here I'm done with my generator. Actually here I want to use for loop because my generator is a iterator, right? I will say for x in my generator function gen Fibonacci, okay. I want to say if x is, now see it, I will say 1 and 0. As you see, it is huge number, you know, it is really big number. I think for this number they call it Google. A Google name also comes there. So this is a Google number. This is huge number. I don't know how many zeros we have here, maybe 30, 40, I don't know. This is huge number. But now my generators, I create a generator and I will not get any error with this number, and I will say here print x, and after that I need to use break. Why I use break here? I said here if my number x is greater than this huge number, print my x, okay. After that break, because in Fibonacci sequence it is infinite sequence, okay. There are infinite numbers of the greater than this number. That's why I need to use break. Only I will print out one number. There are infinite number here after the greater than this number, okay. And now if I press shift and enter, as you see, it is Python is really fast, and it returned my number greater than the first number, greater than this one in Fibonacci sequence. Why is like that? Because as I said here, unlike list, generators generate items one at a time. Now here Python didn't generate the items, the numbers in Fibonacci sequence less than this number, okay. It one time returned with this one and didn't calculate the other numbers in sequence less than this number. But if we create a definition, normal definition, the definition they have to compute, they have to calculate all numbers is less than this number, and after that they can find this number. But generators, they don't work like that. They work only one time, and they don't keep all the data in memory. This is how generator works, and this is how they benefit our programs. This is if we run this Fibonacci, this number in Fibonacci sequence, this is overkill. This is not good good way to create our programs. Okay, now I will also create a normal definition to find Fibonacci numbers, and you will understand how the differences between generators and also normal functions. Okay, I will say here def Fibonacci. Okay, as argument I will say n. Okay, like before I will say a and b is equal to 1 and 1 comma 1. For a is 1, for b is also 1, and I will create here a list, empty list. Okay, result. Okay, we don't have to create a list here and append our numbers, but I want to show you how it is working. That's why. But if you even don't create a list, still you have to keep all the numbers before this number. Okay, this number in the sequence in your memory. Okay, but here with generator you don't keep them, you don't hold them in your memory. Okay, here I will say for I in range n. Okay, result dot append a, and after that here I will say a is a comma b equals b, and b is equal a plus b. Okay, and after that here I will say if a, let's say this number, copy this guy, okay, is greater than this number, so I will say here this is 9 and I need to say 10. Okay, here I will say colon, I need to use here, sorry, I will say break, and also I need to use return keyword, return result. Okay, now if I press shift and enter, as you see I didn't get an error. Here if I call my function Fibonacci, and let's say I think 1000 is enough. Okay, 10,000 or 5,000, let's say 5,000. As you see now it's okay, and let's go to the end. This is my number is that one, right? And my result is this is here. That guy is here, the last item, right? It's here 909 and 1010909. So what is difference here, guys? Now here, as I said, generators, they didn't compute, they didn't calculate the other numbers is less than this one. Okay, but the Fibonacci, the formal function, it calculates, it keeps all these guys in the memory. Okay, we don't need to print it out. Okay, but still they are in memory. Okay, it keeps them in memory. Okay, and this all the guys here is huge big numbers, and after that when it's find our result, okay, this one is if our condition is true, it stops and we say break, it use break. But generators, they don't work like that. Okay, only one time and they find their result, your result, and print them out. But the other normal formal functions, they have to compute, calculate all numbers here for our condition is less than this number, and after that they can find they can reach our condition. This is how generators and also formal functions works, at the very big difference between them, because this is overkill. Okay, this is okay a number, but it can be bigger than this one also, right? You can work with bigger data sets in Python, so that's why you need to use generators. Okay, and after that also I want to talk about creating generators with list comprehensions. As you know, list comprehensions provide a concise way to create lists, and generators also can be created in same manner, but with a small difference. What is a small difference? And also here I will show you something else, and also you will understand how many in our memory normal functions and also generators, how we will measure their them in our memory. Okay, and here, for example, if you want to create a normal list, you need to say here square brackets, right? For example, let's try to find square of our items. I need to say I star star 2 for I in range, I will say 10,000. Okay, this is how we can create a list, right? But if I want to create a generator, it is also very simple. Only what I need to do here, instead of square brackets, I need to use only parentheses. That's all. Okay, now also my generator is ready. Here I will name it gen. Okay, this is simple how we can create our generators with list comprehensions. If I press now shift and enter, as you see, I didn't get any error. Now I want to use a function, it's get size of. Okay, get size of here returns size of object in bytes, and we will check the byte of size of list 1 and also size of our generator function, and you will see huge difference between normal list and also generators. Okay, to do that I will say here let's say print get size of, I will say here list 1. Okay, and after that let's say comma, and here, because as I said, it returns size of object in bytes, and I will say here byte. Okay, for the generator we will measure their size in our memory. For generator is, I will say gen. Now let's press shift and enter. Here what I need to do, I need to also import sys. Okay, now as you see, let's check it. Here our list, its size in my memory, it takes 624. I think this is almost 87 megabytes, something like that, right? And this one, my generator in my memory, it takes only 88 bytes. You see, this is 10 times is bigger than my list 1 is takes 10 times bigger than my generator. You see how generator they are good and how they benefit our Python programs. If you want to create good programs, here you see, maybe we set 10,000. If I set say 1 million, let's check it. This is overkill for the computers. And now as you see, still it is 88 generator, and this guy is, I don't know how many, is million byte. I think is almost gigabyte, maybe, I don't know, something like that. You see how generators work and how they benefit our programs. This is very, very important. And if you didn't understand how generator works, please watch this video again, and also try to read more about generators and try to see more examples about generators. For now, that's all. See you in the next.